You're welcome to today's class. In today's class, we are going to be talking about empirical formula and molecular formula. We are going to dive into the world of chemistry to explore what empirical formula is and what molecular formula is and how they are related to each other and how we can solve problems in chemistry relating to empirical and molecular formula. If you are new to this channel, please don't forget to subscribe and give this video a thumbs up. The empirical formula and the molecular formula. Let's start by defining what the empirical formula is. An empirical formula is of a compound is its simplest formula. The simplest formula of a compound is what we call the empirical formula. The empirical formula tells us the component elements in a molecule of a compound and the ratio in which these elements are combined together. Okay. So what the empirical formula does primarily is to tell us the elements that are contained in the compound and then tell us the ratio in which these elements are combined together to form the compound. It doesn't necessarily tell us the quantity of the element contained in the whole compound. Instead, it tells us that this element is combined with the other element and combined with the other element to form this particular compound, and this is the ratio.
The information that the empirical formula gives. So it tells us the elements in the compound and it tells us the ratio in which they are combined in the compound. It doesn't tell us the actual number of atoms contained in that particular compound. Okay. And the ratio in which the elements are combined in a particular compound is what we call the mole ratio. The mole ratios are found using two formulas. Number one, you can find the mole ratio of a compound by using this equation that the mole ratio of each component element in a compound is equal to percentage by mass of the element in the compound over relative atomic mass of the element. Percentage by mass of the element in the compound all over the relative atomic mass of that particular element. That gives you the mole ratio
of that particular element in the compound. The second equation is that the reactive mass of the element in the compound divided by the molar mass of the element in the compound. The reactive mass of the elements in that particular compound divided by the relative atomic mass of the element. So if you check, you see that you either use the percentage composition of the element in that compound or you use the reactive mass of the element in that compound and then divide it by the relative atomic mass of the element, and you get the mole ratio of that compound, and you can now use it, and you can now use it to do other things you want to do, like calculating, like checking out what the empirical formula is. Okay? Alright. So for example, if you want to find the empirical formula of a compound containing one atom of oxygen and two hydrogen atoms, the empirical formula will give us something like this. One oxygen with two hydrogen atoms, that's OH2. Okay? It will give us something like this, OH2. Alright. So what about if we have a compound containing 3 carbon atoms with 10 hydrogen atoms? Then it will now give us something like this. It will give us something like a C3H10. But it doesn't necessarily mean that this is the whole atom of carbon and hydrogen that are contained in this particular compound. This is just the ratio in which these particular elements are combined in this particular compound. So for us to now find the main atom, for us to now find the number of atoms that are contained in a particular compound, the full number, okay, then we need to check the molecular formula. So let's define the molecular formula. So you see that molecular formula gives us the actual number of each type of atom in the molecule of the compound. The molecular formula gives us the actual number of each type of atom. When we say each type of atom, it means the atoms of the element, different elements that make up that particular compound. So the molecular formula gives us the actual number of the atoms, of the different types of atoms that are contained in a mole of a compound. Okay, so you see the difference between the empirical formula and molecular formula. Empirical formula just gives the ratio in which different atoms are combined to form the compound. But the molecular formula will give you the actual number of the atoms that actually combine to form that particular compound. Okay, so this molecular formula is equal to actual number of atoms. So if you have the molecular formula, you don't need to find numerology. You know that you have this is actually the real number of the atoms that are contained in a part. When you have the molecular formula, you don't need to calculate any other elements. You know that this is actually the real number of atoms that are contained in this of this element that are contained in the particular compound you are referencing to, you are making use of. For instance, if a compound has one carbon atom and two hydrogen atoms with one oxygen atom, then its molecular formula can be written this way: one carbon atom, two hydrogen atoms, and one oxygen atom. That's CH2O. Okay, and of course, this can also be written for empirical formulas. And what if, okay, we check this? Let's say the mass of carbon atom is 12, hydrogen 1, which is this 2, that's 14, plus oxygen, which is also 16, that's like 30. If the mass number of this is 30, but the relative molecular mass of the particular element is 60, then it means that this is actually, then you can use this as an empirical formula to find the molecular formula. Okay, so and that will now take us to the calculation of empirical formula and then the finding of a molecular formula. All right, so if we know the empirical formula of any compound, but we don't know the molecular formula compound, if we know two things, two information, very important. Number one is the empirical formula of that particular compound, and then if we know the relative molecular mass of that particular compound. If you know the relative molecular mass and you know the empirical formula, then it will be very easy to find the molecular formula. And how can we find that? Let's take an example to see how we can find the molecular formula, and how we can even calculate empirical formulas, and how we can find molecular formula using the knowledge of what empirical formula and the relative molecular mass. So stay tuned. So here we have an example. We have find the empirical formula of the compound which on analysis yields the following as the reacting masses. So here we have carbon 2 grams, hydrogen 0.34 grams, and then we have oxygen 2.67 grams. And then the question continues, it says from your result find the molecular formula of the compound if the relative molecular mass of the compound is 60. Or let's say 60 grams. Okay? So here we can see that we are looking for two things. We are first going to look for the empirical formula, and then we are going to look for the molecular formula. And here you can see that we have the reacting masses, and then here we can see that we have also been given the relative molecular mass. So if we can find the empirical formula, then we can calculate the molecular formula, because we will also have been given the relative molecular mass of the compound. So let's solve this question. First of all, we start by identifying the elements that are contained in that particular compound, or the elements that are reacted together in that particular compound. And then when we now get the element, then we now get the ratio in which they are combined in that compound. Okay, so let's get the element. The question said I should find if the compound here on analysis the following reactive masses. So we have carbon there. Of course, we have carbon. We have hydrogen. So we have hydrogen. We have oxygen. Okay. So we have oxygen. All right. Let me write this here. Oxygen. So now, what is the ratio by mass in which they are the results yielded from that analysis? We can see that for carbon we have 2.0 gram, and for hydrogen we have 0.34 grams, and for oxygen we have 2.67 grams. So for us to find this, what do? We need to find the simplest ratio of all this so we can find the empirical formula. Okay? So what are we going to do? We are going to divide each of them by their relative atomic masses. Okay? So now we have the relative atomic mass of carbon to be 12. Then the relative atomic mass of hydrogen is 1. So we divide this one by 1. And then the relative atomic mass of oxygen is 16. So we divide this by 16. Alright. So if we now divide these two, we get this, that 2 divided by 12 will give us 0.17 approximately. Okay, then if we divide 0.34 by 1, it will give us the same thing, which is 0.34. Then if we divide this 2.67, which for oxygen, by 16, it will still give us approximately 0.17. Okay, of course this one will give us 0.1666, but when we approximate it, give us 0.17. This also will give us 0.16 or something or other things. Then when you approximate it, it will still give us 0.17. Alright, so since we have this, for us to obtain the proper ratio, then we look for the smallest value here and use it to divide all these values through. So the smallest value from what you can see here is 0.17. So let's divide this. 0.17 divided by 0.17 is equal to 1. 0.34 divided by 0.17 will give us 2. Then 0.17 divided by 0.17 will also give us 1. So the ratio now, the mole ratio now is 1:2:1. So since we have this as the mole ratio, and the compound that combined together to form this is carbon, then we have hydrogen, and we have oxygen. So we now have that 1 carbon, then 2 hydrogen with 1 oxygen. So this is our empirical formula. This is our empirical formula. So the empirical formula is CH2O. CH2O. So for us to be able to find our molecular formula, for us to find the molecular formula, then we need to make use of this empirical formula and this molecular mass that we have been given. And that will be, if we do that, then we have that the empirical formula, which is CH2O in brackets X, where X will give us these elements to it to give us the real number of atoms in this particular molecule. Okay, so this will now be equal to 60, because we are told that the total mass here is 60. Alright, so we are going to do what? We are going to find x. Okay? We already know that the atomic mass of carbon is 12. And the atomic mass of hydrogen is 1. So 1 times 2, which will give us 2. Then the atomic mass of oxygen is 16. 2 plus 16. So 12 plus 2, which is 14 plus 16, will give us 13. Okay? So we'll have it to be equal to, therefore, to be equal to 30x equal to 60. Okay? So that x will be equal to 60 divided by 30. So if we divide through, we'll have 2 over 1. X will be equal to 2. Okay? So since we have our x to be equal to 2, then our molecular formula will now be equal to C2 H. Since we already have H2 here, then 2 times 2, which is H4. Then O2, which is yes. So this gives us our molecular formula. We can also rewrite this molecular formula to give us something like this: CH3COOH. Anyway, we write it. So this is our molecular formula, and this is our empirical formula. So from this, you can see that the empirical formula only gave us the ratio in which the component atoms, okay, the atom that compose, the element that compose the compound, it only gave us the ratio in which they combine together. But now we can see that the molecular formula now gives us the actual number of atoms of each of these elements that are contained in mole of the compound. Alright. So we will solve more examples and more examples. So make sure you subscribe if you are new to this channel, and share this video, and also give this video a thumbs up on the notification button, so that when we upload more examples and more life solved problems on this particular topic, you will get to know about it, and then you will get to learn more from it. So see you in our next class.